Hey guys, great to be back with you all again today. We're going to be talking about problem solving again, and the specific skill we're going to talk about is 3.4K, solve one-step and two-step problems involving multiplication and division within 100 using strategies based on objects, pictorial models, including arrays, area models, and equal groups, properties of operation, or recall of facts. And basically, in any problem solving, probably one of the biggest problems third graders have is being able to choose correct operations. So I can use the correct operation to solve word problems. Talk about the vocabulary really quick. For multiplication vocabulary, the factors, there's a factor times factor equals a product. So the factors are the numbers we put together in a multiplication sentence, and the product is the answer. And division vocabulary, we have dividend, divisor, and quotient. One thing you notice about multiplication, there's a community property in multiplication. That means I can switch the numbers around and I'll still get the same product. That's not a fact in division. There's specific order. Division is similar to subtraction. We start with a big number, typically in third grade, and we're going to divide it by the divisor, and then we'll get the quotient. Okay. But quotient, remember, quotient is the answer to a division problem. Product is the answer to a multiplication problem. I got some videos we're going to watch. The first one we're going to watch is Aaron's 5-minute math video, and he's going to be solving a problem, a STAR test problem over the skill that we're talking about, 3.4K. And then we're going to watch a video that I made about how to make a multiplication chart. And then a third video about how to use the multiplication chart to do division. So let's get ready and watch these videos.
And division problems. This is standard 3.4K in the great state of Texas, and we're using item number 37 of the 2016 released STAR test. If you have not done so already, please go ahead and take a moment, pause the video, see if you can work this problem out on your own, and then unpause it. We will look at our answers together. So this standard has both one and two-step problems, and this happens to be just a simple one-step problem. So we have Miss LaSoya. She's got 72 index cards. She's going to arrange them into 6 equal stacks, and then how many index cards are going to be in each stack. So our only clue here is going to be this term equal stack. So whenever we're looking at equal groups or equal stacks, that means that we are going to use either multiplication or division, because multiplication and division only work when you're dealing with the same size groups or equal groups. So we see equal groups. Also, each typically gives us a clue that we're looking at either multiplication or division. So we can go ahead and knock out a few of these answers, because you've got 72 and 6. So if you're not sure what to do, you can add the two. 72 plus 6, that's going to make 78, and that's where this answer comes from. That doesn't make any sense. How can there be 78 cards in each stack when you only have a total of 72? Some students might want to subtract the 2. We can regroup here, and you can see we're going to get 66, which is our answer selection here. Once again, that doesn't make any sense. If you have 6 equal stacks of 66, it's going to be a heck of a lot more than 72. So both of these are incorrect. And so what we need to do is we're going to need to either multiply or divide, and we can just use logic here saying both of our answer choices, 12 and 9 that remain, are smaller. And so when we get smaller, we're going to be dividing. Dividing is what makes it smaller. Multiplication typically makes our answers bigger. And so let's see if we can draw a picture of this just to kind of represent what we're doing. And we'll look at a few different ways that we can solve it. So if I wanted to make a strip diagram, I could do like this. I can say, look, I've got 72 total, so that's my max. That's why that 78 doesn't work. It's larger than my total. And I'm going to do 6 groups here. So I cut it in half, then cut each half into thirds. I've got 6 groups. So those are my 6 equal groups, and how many can I put into each? So if I do know a multiplication fact, I can probably get that done. 6 times something makes 72. But I don't necessarily know my 6s all the way up to 72, so let's see what let's just see what we can do with some division. So we could literally just take this graph that we have here, this strip diagram, and we could just take our 72 and we can just split them up. So we can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and just keep going until we run out. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Now I've got 6 sets of 5, that makes 30. If I do 30 plus another 30, that's going to give me 60. So I'm just going to use my brain here a little bit. I'm going to put another 5 into each of these just to save me some time. Now that I figured out that 6 sets of 5 make 30, 10 sets of 5 is going to make 60. So that's going to make sense. Is if I can get that up to 60, because I've got so far 10, 20, 30, 40, 50, 60. Now I can go a little bit slower. 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72. So there we go. It looks like I have got sets of 12. 6 sets of 12 would make 72, or my number sentence could be 72 divided into 6 equal groups. It's going to give you 12 in each group. So our answer is going to be A, 12, and 9 is just another option that's smaller, but I'm not sure how we're getting 9 from there. And so we can finish this problem here by looking at 72 divided by 6 equals 12. This is represented with a strip diagram, as is this, because multiplication and division are inverse operations, and you can represent them both with the same strip diagram.
Okay, we'll go ahead. In this lesson right here, we're going to go ahead and talk about how to make a multiplication chart. And we all should have lined paper. So I'm just going to show you how to do it with the lined paper. This would be the preferred way to do it if you had grid paper. And this is a copy of the STAR grid paper that we use for the STAR test. And we use it at school a lot here too. So that'd be the preferred way to do it. But if you don't have lined paper or grid paper like that, you can use a piece of lined paper, just regular piece of notebook paper. And this is what I'm going to do. I went ahead and counted down 12 lines. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I put a little mark right there. And I'm going to go ahead and use that red line as the outside part of my multiplication chart. Then I'm going to take it all the way over here to this other red line I can kind of see through here. And that should be pretty close to square. Right there. And then I'm going to try to make 12 equal sections right here. I'll go ahead and break that in half first, because make a line straight down and break it in half. And if I take I still need 6 on each side, so I'll go ahead and break that one in each side in half. Now inside of there, I need three sections inside each one of those sections I made. So that's going to be 1, 2, 1, 2, 1, 2, 1, and 2. And that should be 12 sections. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I got 12 sections now. So I'm going to just take them all the way down. They're relatively close to the same size. They're not exactly by any means, but close enough for to work for us. And what I'm going to do is on the outside, I'm going to put my factors. So this is a multiplication chart that we're making. And on the outside of our multiplication chart is our factors. First thing I'm going to do is I'm going to put an X right here in the corner, and we're going to learn our zero facts all the way through 10. So that's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And then going down, we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So those are all our factors, and we're going to put the products in here and to find our products. And this is also a good way to help us kind of memorize our facts. So going across all of anything I multiply by 0 is going to be 0. So 0 times 0, 0 times 1, all the way to 0 times 10 is all 0. And going down, 1 with nothing in it is 0, 2 with nothing in it, 2 groups with nothing in it. So these are all 0, so that's easy. And then go ahead and start on our 1 facts. So 1 times 1, 1 times 2, times 3. So basically I'm just skip counting by 1s, right? So, and 10. And then going down, 2 groups of 1 would be 2, 3 groups of 1 is 3, and so on. So 4, 5, 6, 7, 8, 9, and 10. So that's a good part of our multiplication chart right there, just our 0s and our 1s. We're pretty good at skip counting by 2s. You would have really mastered that last year. So I already have 2 right there. So 2 times 2 is 4. Then times 3 is 6, 8, 10, 12, 14, 16, 18, and 20. And going down, 3 times 2. So it's 2, 4, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. The next thing that you would have been pretty good at, I know in kindergarten, y'all know how to count by tens, or you would have learned how to count by tens in kindergarten. So we'll go down here to the tens. That's probably the next easiest thing that we can do is, so we got 10 times 0 times 1 times 2. So that's 30, 40, 50, 60, 70, 80, 90, and 10 times 10 is 100. And then we'll get them going down too, so that'd be 30, 40, 50, 60, 70, 80, 90, and 100. So we're getting pretty far along here. Still another one we learned pretty good is our 5s. You should be really good at skip counting by 5s. So we'll go to our 5s line. We'll do that across. I already have 5 and 10. So after that would be 15, 20, 25, 30, 35, 40, 45, and 50. Sometimes self-checks in there because when I get to the end, I know 5, 10 times is 50. Going down, we'll do the same thing. We already have 5, 10, that'd be 15, 20. There's our self-check, 25, 30, 35, 40, 45, and our last self-check is 50. Okay, so we've got all those done right there. And really, we don't have too many more blocks to fill in. We've already answered most of the multiplication facts just from stuff that we've basically learned in kindergarten. So I'll go ahead and start to teach you maybe to me, the next easiest facts for you to learn is probably your 9s. And that seems a little bit daunting, but it's not really. There's some tricks to it. And I'm going to show you this trick really quick here. We'll give it a try. So basically, you start over here on your paper, and you start at 0, and go 1, 2, 3, 4, 5, 6, 7, 8, 9, and you stop at 9 right there. And then we're going to go back up to 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that's pretty easy. And that's all of your 9 facts through 10. So 9 times 1, 9 times 2, 9 times 3, times 4, times 5, times 6, times 7, times 8, times 9, and times 10. That's all of your facts. And all you had to do is start at 0 to 9, and then 0 back up. And that gives you all of your 9 facts. Show you something else about your 9s. If you add the digits together, they all equal 9. So 0 plus 9 is 9. 1 plus 8 is 9. 2 plus 7, 3 plus 6, 4 plus 5, 5 plus 4, 6 plus 3, 7 plus 2, 8 plus 1, and 9 plus 0 again. They all equal 9. And we'll go ahead and use that to fill it in. We'll talk about some other patterns later on in your nines. Nines have a lot of pretty cool patterns that I like. So we look, we'll start going down. So that's 18 we already have there. Then it'd be 27, 36, our self-check, 45, and then 54, and then 63, then 72, and then 81. And then going across, 27, 36, 45, 54, 63, and then 72, and our self-check 81 and 90. So you see we've pretty much filled in all of our a good part of our facts right there. We have a few right here and a few over here. Not too many facts we really have to memorize. Okay, the next thing, some people are pretty decent in counting by threes. I'm not necessarily really good at counting by threes. But if you did want to fill it in, you just add 3 each time. So 6 plus 3 is 9. 9 plus 3 is 12. 12 plus 3 is 15. It's already there. And you can do that. Okay, the next thing they really teach, they really want you to learn, we call them square facts, or square facts. So the square facts are going to be the ones where we're multiplying, both the factors are the same. So 0 times 0, 1 times 1, 2 times 2, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, and you already have 9 times 9 is 81, and 10 times 10 is 100. So you see we filled a lot of those facts in already. The fours is just double. So if I'm multiplying something by 4, double 3 is 6, and double 6 is 12. We already have 4 times 4. 4 times 6. Double 6 is 12, and double 12 is 24. 7. Double 7 is 14, and double 14 is 28. Okay, and 8's a little bit, 8's easy to double, but once you get to, if you double again, it's a little bit harder. So we just add 4 to 28. So 28, 29, 30, 31, 32. And then we have the same, reverse community property going down. So you could just go ahead and copy. So 3 times 4 is the same thing as 4 times 3. So that's 12. We already have 16, 20. 6 times 4 is the same thing as 4 times 6, 24. And then 7 is 28. 8 is 32. And we already have the rest of them. We can go back and get our threes. We only have 3 more threes right there. So 15 plus 3 is 18. 18 plus 3 would be 19, 20, 21. 21 plus 3 is 24. And we have the rest of them. So all we can do is transcribe those down here. So 3 times 6 is the same thing as 6 times 3 is 18. 7 times 3 is the same thing as 3 times 7, 21. And 8 times 3 is the same thing as 3 times 8, which is 24. And we have the rest of them already. Only have a few more. We have 1, 2, 3, 4, 5, 6 more facts to fill in there. And we could just do regular addition. So on this one, since I'm going across, I would add 6 every time. And use your fingers if you want. But 36, 37, 38, 39, 40, 41, 42. And then 42 plus 6 is 48. And I'll show you another trick on your 6s. 6 times 7 is basically just going to be another 6. We could go add 6 more right here because I know that 7 times, I know we already have it right there, 42, but 35 plus 7 is 42. 6 times 8, so I know 5 times 8 is 40, so it would be another 8, 48. And then we only have 2 more facts. I think it's the same fact, 7 times 8. And 7 times 8 is one that I like to quiz people on a lot because it's just one that seems like people struggle with a lot. And I got a little trick for that one too. If you go 5, 6, 7, 8, so 5, 6, 7, 8, 7 times 8 is 56. So you're just taking the 2 numbers that are before 7 and 8, and it's 5 and 6, 56, and 7 times 8 is 56. And there we go. We did the whole entire multiplication chart, and even with me talking you through it and showing you some tricks, we still got it done in like 14 minutes there. So it doesn't take a long time, and we're going to practice this. By the end of the year, you should be able to make one of these in probably under 5 minutes. It really doesn't take too long. Definitely when you learn your multiplication facts. And this is something you'll use a lot. You can use this all year long. And when you get to 4th grade, it's going to help you a lot when you get to your long division. There's some really cool tricks on using a multiplication chart to do long division with too. So just this is one of the things we're going to practice throughout the year, and we're going to get good at it. And we need to memorize all these facts. We need to memorize all the facts through 10 times 10. So that's just something, taking some flash. Okay, I'm going to talk about how to divide using a multiplication chart. If you're not really good with your multiplication facts, division is going to be kind of difficult. So you can always use a multiplication chart that you make in class. So I'll give you an example here. We have 49 divided by 7. Okay, 49 is our dividend and 7 is our divisor. So if we're going to use our multiplication chart, we got to go and find our divisor and our factors on the outside of our multiplication chart. And I'll highlight the factors. Okay, these are our factors right here. The outside of our multiplication chart are our factors. So you go ahead and you find the divisor. Okay, and you follow it over until you find the dividend. So once you find a dividend, you take it straight up. So 49 divided by 7 equals 7. Okay. Try another one. Okay, 56 divided by 8. Okay, with 56 divided by 8, 8 is our divisor. So we're going to find 8 on our multiplication chart. Okay, you follow it over until you find 56. And then you follow it up until you find the other factor, which is 7. So 56 divided by 8 equals 7. I'll try another example. 25 divided by 5. Okay, 5 is our divisor, so we find that on our multiplication chart. Okay, 5, we follow it over until you find 25. Okay, once you find 25, you go up. So 25 divided by 5 is 5. Okay, and do another example. 24 divided by 8. Okay, you go ahead and you find your divisor, which is 8 on your multiplication chart. You follow it over until you find 24, then you go straight up. So 24 divided by 8 is 3. So now that you know how to use your multiplication. Okay, we're working on some guided practice problems here. Follow along as I read. It says, Dora and Nicole are baking brownies. Okay, they make a tally mark on a clipboard each time they make 6 brownies. What is the total number of brownies Dora and Nicole have baked so far? So we're going to go ahead and we're going to circle some important information. And the 6 brownies. And she's making a tally mark for every time she makes 6 brownies. So we need the picture of the clipboards Nicole and Dora have right there. And then I'm going to underline the question. It says, what is the total number of brownies Dora and Nicole had baked so far? So we're going to look at this problem right here, and we're going to talk about how many groups there are, how many are in each group, and what is the total. So on this problem, so I'm going to use a get strategy. So G, E, and T. So do we know how many groups there are? Yeah, we know how many groups there are. The groups are going to be the tally marks. Now you can see I've got 5 here, 5 here, that's 10, and then 3 more tally marks altogether. So that would be 13. So I got 13 groups. And those are the tally marks. I'll put a T right there. Do you know how many are in each group? Yeah, right here it says each group right there has 6 brownies in it. So each tally mark represents 6 brownies. So I put 6 brownies. Do I know what the total is? No, I do not know what the total is. That's what we're trying to find out. That's going to be the total amount of brownies that she made. So we got a lot of different ways we can solve that. Okay, we could use a standard algorithm. We could use 13 times 6, and that's typically the way that we want you to be able to do it, because it's going to be the quickest way of doing it. So that'd be 13 times 6, or really, yeah, 13 times 6. So first thing I'm going to do is multiply 6 times 3. 6 times 3 is 18. Then I'll regroup over here. And then 6 times 1 is 6 plus 1 more is 7. So that means that it looks like they baked 78 brownies. So I'll put a question mark right there. Another way of doing it, if you're not really good with the standard algorithm, we can do an area model. To do it, I go ahead and make a rectangle. And we'll say this part of the rectangle right here would represent the 6. Okay, this part of the rectangle right here is going to represent the 13, but I'm going to break it down into 10 plus 3. I'm basically going to use expanded notation. I can fill in this part of it. That part of the rectangle would be 6 times 10, or 60. This part of the rectangle right here would be 6 times 3, or 18. And then to figure out what that is together, I would just add 60 plus 18. So that's 60 plus 18. That ends up being 78 too. So I showed you 2 different ways to solve the same problem. And 78 is the correct answer. They baked 78 brownies so far. Okay, let's look at the next problem together. Follow along as I read. It says, Felix found 6 coins using a metal detector. Anakoi found 3 times as many coins as Felix. And Simon found half the number of coins that Anakoi found. How many coins did Simon find? So I'm going to circle my important information. I got Felix found 6 coins. Anakoi found 3 times as many coins. And Felix found half the number of coins. Okay, so when I look at these numbers right here, look, I got a lot of information. Okay, I'm going to use a table to help me solve this. So I'm going to go ahead and put an F right here for Felix. And I know Felix found 6 coins, so I'll put that right there. A for Anakoi, and then an S for Simon. Okay, so to figure out how many Anakoi found, I would multiply 6 times 3, because times is telling me that I need to multiply. So what is 6 times 3? Yep, 6 times 3 equals 18, so that means Anakoi found 18 coins. So What am I going to do to figure out how many coins Simon found? Yep, it says half, okay? And a half means divide by 2. So I'm going to divide by 2, and I would do 18 divided by 2. Figure out what that equals. Okay, and there's a lot of different ways to do it. Okay, I could go ahead and make 2 equal groups. Make 2 equal groups, and I separated the 18 out. Okay, I'm going to start with 5s, start by 5s, put them in there. So that'd be 5, 10. Okay, but if I went to 15 and 20, I wouldn't be able to do that. So I'm going to start counting by 1. So 10, 11, 12, 13, 14, 15, 16, 17, 18. So I can see that 18 divided by 2 would be 9. So that means Simone found 9 coins. And that's the answer to our problem. Okay, it's time to complete our independent practice again. Please take your time, do your very best. I'll put a PDF in there that you can print out and do it on pencil paper if you like. Okay, but there will be a blue puzzle piece in there with today's date on there. So go ahead and input your answers into Schoology. If you have any problems, something doesn't seem like it's working like it should, please send your teacher a message in either a message in email or send a message in Schoology, and we'll get back to you just as soon as we can. And take your time, do your very best, and best of luck to you. We'll talk to you later.